types of problems we need to take a look at. One is with numbers or integers. And our example problem tells us that we are dealing with the reciprocal of the product of two consecutive positive integers, and that reciprocal is going to equal 1 over 24. So we just need to remember what the words mean. Reciprocal just means you're going to invert it. So if you had 1 over x, that will become x over 1. If you had 2 over 3, that reciprocal is 3 over 2. So you're just taking the numerator, making it the denominator. Denominator becomes the numerator. Product means you're going to be multiplying something together. Consecutive, those are numbers that come right after each other. So 1 and 2 are consecutive numbers. 93 and 94 are consecutive numbers. And they're integers, so they're whole numbers. So let's let x equal our first integer. In that case, the consecutive integer, the one that comes after this, would be x plus 1 equals our second integer. So if I could find x, I could find the consecutive one. Okay, the product of these two integers. So product means x times x plus 1. Okay, I've got that. And now we want the reciprocal of the product. So reciprocal would mean I take this, and by default that's really over 1. So the reciprocal is 1 over x times x plus 1. And that's going to be equal to 1 over 24. So that would be our setup for this problem. Okay, our last type of problem we want to take a look at is the rate, time, distance problem. So let's grab our problem. And these problems, the key is that we always have some rate or speed that we're moving, multiplied by some time is equal to some distance. So let's say we were going 30 miles an hour and we drove for 2 hours. 30 times 2 is 60, so we would have traveled 60 miles. And as long as I know 2 of the 3 of these variables, I can solve for the third one. So I want to create a table. Rate multiplied by time equals distance. Okay. Okay, and so we've got a motorboat traveling 20 miles per hour in still water. So that's water without any sort of current. If the boat can travel 3 miles downstream, okay, so let's make one of these downstream. And it can travel 3 miles, so I'll go ahead and put in my time here, or my distance, 3 miles. In the same time it takes to travel 2 miles upstream. Okay, so this one will be upstream, and it goes 2 miles. Okay, so if we're going downstream, do we have a current working with us or against us? And so when we go downstream, the current helps us. So we can go 20 miles per hour plus the current. So we might want to make a note, x equals our current. If we're going upstream, we still go 20 miles per hour, but the current is pushing us backwards, so we have to subtract the amount of the current. Okay, so I've got my rate and I've got my distance for each of these directions. Now I need to figure out, how do I figure out time? So if we think back to a driving example, if I drove 60 miles and I was going 30 miles per hour, how did I figure out the time? I would take my 30 miles or 60 miles and divide it by the speed I was going, the 30 miles per hour. So we're doing the same thing here. I take the distance we went, 3, divided by the speed I was going at that time. Same way when we went upstream, I take the distance I went upstream and the speed I went upstream. So now I have my times. The other thing we need to look for in the problem is, what about these times do we know? Do they equal each other? Do they add together to give us some number? So we come back over here and it says, if the boat could travel 3 miles downstream on a river in the same time, So same tells us they're equal. So the way I would set up my equation to solve for x, I would take the time going downstream, so 3 over 20 plus x, and I make it equal to the time going upstream. And again, this is how we would set it up. Rate, time, and distance. And because we have the same times in here, I set them equal to each other. The next video we will talk about how to solve this type of problem.